Okay, hello. Minimize that. Let's get started here. Chapter 5, Section 7, titled Using Proportional Relationships. In other words, we're using similar triangles. Example 1, measurement application. So this is where similar triangles come into play. This is a real-world application. It reads, Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow, and then made a diagram. What is the height, h, of the pole? Well, if you notice, over here is the telephone pole from G to H. So lowercase h is the height I want to find. Its shadow is 38 feet 4 inches. At the same time of day, Tyler, who is 5 feet 9 inches tall, his shadow is 7 feet 8 inches. So we have similar triangles. So we're going to set up a proportion that's going to look like this. But before we do that, let's convert everything into just inches. Well, 5 feet 9 inches, that's 69 inches. 7 feet 8 inches, 7 times 12 plus 8 is 92. And then 38 feet, 38 times 12 plus 4 is 460. That way everything's in inches. And I would set this up, I always like to start with the h. H corresponds to the 69, or the height of Tyler. I keep that proportion. 460 over 92 would be my next fraction. And we've cross multiplied 100 times already. That means that h comes out to be 345 inches. And if you divide by 12 and convert it, it is also 28 feet 9 inches. So the height of that pole is 28 feet 9 inches. Again, that's using similar triangles. Look at the next slide. It reads, on a Wisconsin road map, Kristen measured a distance of 11 1/8 inch from Madison to Wausau. The scale of this map is 1 inch to 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? So let's set up a proportion. What we're going to do is start with the, which is also called the scale factor, 1 inch, 13 miles. Then we're going to use this 11 1/8, and it has to go on the top. Oops, not 1/2, sorry. It should be 11 1/8 inches. Inches have to go on top because I'm trying to figure out how many miles it would be. So I'll call that one X. So if I use my calculator and take 13 times 11 1/8 and then divide by 1, which doesn't change anything, X here comes out to be 144 5/8, which would be a good answer, but the directions say to the nearest mile, so we want to round it to 145. The next slide, we're going to skip one. I have to skip it because I think the diagram's too small to read. Sorry about that. Go on to the fourth slide. This one says, Lady Liberty holds a tablet in her left hand. Now we're talking about the Statue of Liberty in New York City. The tablet is 7.19 meters long and 4.14 meters wide. I'm sure if you Google that, you would find that to be true. If you made a scale drawing using the scale of 1 centimeter to 0.75 meters, what would be the dimensions to the nearest tenth? Well, you need to do this problem twice, one for the length and one for the width. So I will start off. My scale factor is 1 centimeter to 0.75 meters. And I'm going to do the length first. So this 7.19 meters long, and that would go, need to decide, does that go on the top or the bottom? It has to go on the bottom to keep meters on the bottom. I'll put an X where that goes. When I cross multiply this, it comes out to be 9.6 centimeters. Now we have to repeat the process for the width. But I start it 1 centimeter over 0.75 meters again. And I'm going to use this 4.14 meters. X goes there. Cross multiply. X this time comes out to be 5.5 centimeters. Again, that's just some calculator work that I'm sure you can do by now. Let's move on to slide 5. Similarity, perimeter, and area ratios. What this is saying is, if you look at these triangles over on the left, A, B, C, and D, E, F, you see the 5 goes with the 10, 3 goes with the 6, look for a pattern here, 4 goes with the 8. You see it's doubling every time? Well, if I go the other way, instead of times 2, it's really times 1/2. So my similarity ratio is 1/2. But look at my perimeter ratio. If I take the perimeter of the first triangle, I get 12. And the perimeter of the bigger triangle, I get 24. That also comes out to be 1/2. So if your scale factor is 1/2, then your perimeter ratio is also 1/2. But it's a little bit different with the area ratio. The area of the first triangle comes out to be 6, and the area of the second triangle comes out to be 24, which is 1/4. So it's 1/2 squared. That's always the pattern. Let me give you another example. If your scale factor, let's say, was 1/4, the ratio of your sides, then your perimeter ratio would be the same, 1/4. But your area ratio would be 1/4 squared, or 1/16. That's always the pattern it's going to take. Knowing that, on the next slide, I've just summarized it. If the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is also A over B, and the ratio of their areas is A squared over B squared, or A over B squared, same thing. Last slide, let's do an example. Given that the triangle LMN to triangle QRT, find the perimeter P and the area A of QRS. Okay, so let's do a side. 13.9 goes with 9.1. So that's where I'm going to start. 13 over 9.1 would equal the same as the perimeter. Well, the perimeter of the first one is 36. So 36 on top, X on bottom. So cross multiply, solve that. I get X is 25.2. And that would be centimeters. Which means the perimeter of this triangle is 25.2. And I did that just using those two given sides. Now I want to do area, but remember this is where we square it. So I'm going to start with 13 over 9.1, but I want to square each of those. And that would equal this 60 over x. Again, you have to square the sides. 13 squared over 9.1 squared. So when you cross multiply that, you get 29.4. So the area of this second triangle is 29.4. Okay, that's your video for these notes. We've practiced these in class. Thanks for watching.